Okay, can you see?
Yes, carry on.
Okay, so one of the things that we're also looking for in our hydrogen is what we call or in this case, our tritium. It is called a diamond structure. And the diamond structure comes from the carbon, and it comes in the form of crystals. So what we do is we put these our tritium out in the sun, and here in Arizona, our sun is very high. So you can see it forms these white crystals. Now, some people will say that they're salt crystals. Some people will say that they're sodium crystals. They may well be, a little bit of all of it, but they're also nano nanocarbon crystals.
Do you know how to test it?
So the way we test it is if it dissolves in water, it's salt, and if it holds its structure, it's carbon or sodium crystals. But we actually try to grow these crystals a little bit. So
And what do you use them for?
We put it in our mixture. This would be crushed up and become our tritium, including the
So
salt
these
around
crystals, they are your tritium?
Yes.
Or the orange dust?
Both. All of it.
Now I'm going to give you bad news.
Okay.
I'll give you a test news. You know these crystals you separate, the clear one?
Yes.
You said they don't dissolve in the water.
Some do, some don't.
Okay, the one who don't do. If you get and go back to the old time of the diamond testing, if you scratch it on the glass or on the mirror, see if it scratches the glass or the mirror.
Well, I imagine they haven't grown to that degree where they're strong enough.
One single cell can do.
Yeah.
Then it gives you, if you have managed to achieve crystal structure in a diamond way in the matter state. These are simple tests we've spoken about before. So if you separate these and then you see the scratches the glass, because in a liquid state you could not catch them, then you have produced diamond structure. And then this is 100% H2. It's very hard for H3 to make crystal of itself because of its composition. But H2 can. Because if you look at the H2 structure, it's in a way, if you put 6 of it together, it gives you 1 carbon cell. That's why H2 becomes and can become what you see as a salt, as crystals. So if you be a bit ambitious and take it a step further, you can grow these what you call salt pieces, because they don't dissolve, to about 5 to 10 carats diamonds. There's a specific way to do it, to grow it, and you can cover these, you let them grow in the liquid state, and when they dry, they take a bigger shape. I've made bigger size, I was speaking before. You have to use a specific configuration to pull the plasma apart, to extend it into a diamond structure. And then you can make 10, 20 carats of diamonds. And the only way you do, when you diamond test it, it tells you it's diamond, that's the only way you can do, or when you scratch a mirror on it and it gets scratched, if it doesn't get scratched, it means you haven't got there. And with the smallest thing, it makes a specific noise, and you can cut the mirror with it. You see the scratch on it. But
so even though we don't have the big crystals, don't we have nano carbon structure? That
you haven't,
part
you
of
could have, but it's not a carbon structure. The ones which dissolve, usually the ones which dissolve come out of Hc3. CH3 there, it gives you the characteristics of the energy, but in general you are producing, if you test it, hot water test it, the best way to test this crystal is not in the cold water, you do it in the hot water, and you still see that there, now it means you have created the diamond structure. Then if the second thing is, if you're a diamond tester, you just go on and it goes and it goes into the line, it tells you you have a diamond, or you allow it to grow and have a biggest diamond in the world on your finger. That is incredible. So what you actually create most of the time, majority of the time, these crystals you collect is carbon structure. It's a H2 diamond structure, which in fact due to the composition